Hello, good afternoon. My name is Fabien Roques. Welcome on this webinar. So I'm an executive vice president with the consulting company Compass Lexicon, which is an economics consultancy. And I'm here with my colleague Catherine Doulache.
Hi.
We've been working together quite a lot on the issue of carbon pricing in Europe and the compensation for potential carbon leakage in Europe, and it's a pleasure to welcome you on this webinar. In terms of logistics, we plan to talk for about 40-45 minutes. We will make sure that we stop a number of times for you to have an opportunity to ask questions and for us to answer your questions. So let me perhaps give you an overview of what we are going to discuss. So we will start with a brief introduction, of course, on why carbon pricing and the compensation for potential carbon leakage is relevant to Europe at the moment. And we will put that in the global context of the recent developments in terms of carbon pricing. We will focus in the third step a little bit more specifically about carbon leakage. It is a topic that is very much being discussed, but often we lack a robust definition and a robust economic approach to carbon leakage. So it's our intention in this webinar, and you see it's going to be the focus of the fourth part of the webinar, to provide a robust framework to think about carbon leakage. And finally, we will look at what the European Commission has put in place to deal with that risk of carbon leakage. We will try and explain to you the compensation framework that has been put in place both to deal with the direct emission cost, so the fact that you emit CO2, you have to pay for the cost of CO2 as an industrial, and the indirect potential cost via the channel of the electricity price, which is the fact that when you consume electricity which is being produced from thermal plants, if the carbon price increases, then you are indirectly affected. So that's the plan for today, and let me suggest we start right now with the quick introduction. So you know very well that the European Commission has set a quite ambitious target for decarbonization. You also probably have heard that the new European Commission is actually discussing an increase in the target for greenhouse gas reductions compared to what we have here. Importantly, the ETS, the European carbon market, has always been thought as the cornerstone of the EU policy to combat climate change. And it's been a major achievement worldwide because it is still to date the biggest carbon market. Now, obviously, a carbon pricing approach makes sense from an economic point of view, but you have to be worried of what are the implications for the economic competitiveness of your industry if it's not symmetrically applied, meaning if there is a differentiated approach in other regions of the world, which, for instance, do not apply carbon pricing or do apply carbon pricing with lower levels. And this is what leads to carbon leakage. And as I said in this presentation, we will provide you an update of the status of the ETS, global carbon pricing, but also the risk of carbon leakage and how the European Commission is dealing with it. Let me remind everybody of how the ETS works in Europe. It's a pretty simple story. We have essentially a cap and trade principle. The idea is that you will define a maximum amount, a maximum limit of emissions. That's your cap. And then you will allocate these permits to emit CO2 to the different market participants up to a certain level, and obviously the sum of these allocations needs to be equal to the cap. Now, importantly, you want to create a scarcity. So there needs to be fewer credits compared to what is needed by the market participants, which will lead to a natural demand for credits, trading, and from that process will emerge a price. Now, the economic literature tells us that this is the most efficient way essentially to drive emission reductions in the sense that this is the least cost way, if the market is well defined, to drive emission reductions. Now, let's look at the practice. In practice, I'm showing you the history of the ETS, starting from phase 1, 2005, the very beginning of the ETS in Europe. Phase 2 started in 2008, Phase 3 in 2013, and Phase 4 is due to start in 2021. What you see first is that there's been a gradual increase of the sectors included in the ETS. Initially, it was essentially large industries and the power sector. Aviation joined from 2012, and a number of other industries joined during Phase 3. In terms of the geographic scope now, we started in Phase 1 with the EU 27, a number of other countries joining in Phase 2, Phase 3. Finally, in terms of gases covered, the ETS is not just anymore about CO2. It started with CO2 and it's been extended to a number of other gases. The other thing that's of course important is that the ETS has had a somewhat chaotic life. If we look at prices over the past 15 years, more or less, you see that there's been, of course, peaks and troughs. Phase 1 was a trial phase. So the collapse of the carbon price you see at the end of Phase 1 was due to one design issue, the fact that you could not bank into Phase 2 your excess of allowances. So the prices of ETS allowances collapsed to zero when the market participants realized there was a surplus. This has been fixed in Phase 2. You can now bank your credits, and as you see, the prices did not collapse to zero, even though we have had a long period of oversupply, which was primarily driven by the big economic recession we had in 2008, 2009. What's important is also the more recent story. You see that prices in the past 18 months have increased very significantly. That is largely the result of reforms. There have been a series of reforms to the ETS to restore the supply-demand balance. So that's Europe, and perhaps let me tell you a little bit more about the status of carbon pricing around the world. So you see here a good map from the World Bank carbon tracker. So it's a publication that's updated every year. What you see is that in green, there are a number of carbon markets implemented around the world or being considered for implementation. So for instance, some of the US states, Canada, but also Kazakhstan, and some of the big cities in China have an operational carbon market. You also see in blue or in yellow other forms of carbon pricing. For instance, carbon taxes, either existing or under discussion. Another way to look at that is perhaps to look at the percentage of emissions covered globally by carbon pricing. And the way to read this chart is that from 1990 to 2020, there is a gradual increase, as you see, of the share of annual greenhouse gases emissions covered. In the 90s, it was essentially the Nordic countries having implemented national taxes. This covered a very small part of the total emissions globally. The ETS started in 2005 and was a very significant jump. As you see, it added a good coverage. And gradually other countries joined the club. Today it's about 20% of the global emissions, greenhouse gas emissions, which are covered by carbon pricing. And it could increase very significantly indeed if China follows on its plan to implement carbon pricing by 2020. So the overall conclusion is that it's been a long road in Europe. The pace is picking up globally, but when we look at the reality today, another way to look at it, perhaps less optimistic, is that 80% of the global greenhouse gas emissions are yet not covered by carbon pricing. And the immediate question that this begs is, of course, if we have asymmetric pricing of CO2 between Europe and the rest of the world, we will have to deal with carbon leakage, or at least the possibility of carbon leakage. Let me see if there are any questions at this stage. If you have any question, please feel free to write us, drop us a line on the chat, and we will, of course, try and answer them as we speak. Don't think we have any questions, so perhaps we will transition to the issue of carbon leakage, and I'll hand over the floor to my colleague, Café.
Yes, thank you, Fabien. So Fabien has just presented the carbon pricing and the different mechanisms around the world. And now we're going to talk about the carbon leakage risk. So what is carbon leakage risk first? So carbon leakage refers to a situation when a unilateral climate regulation in a certain jurisdiction, such as the EU ETS scheme in Europe, leads to its transfer of production to other jurisdictions, meaning that companies in the EU, because they face higher emission costs, will relocate to countries with less stringent climate regulations. So we call it carbon leakage because the transfer of businesses in jurisdictions with less stringent climate regulations will lead to an increased total global emissions, because these companies will eventually increase their emissions abroad, which will increase the global emissions. So those sectors that are exposed to carbon leakage are typically industries that are energy intensive or electricity intensive, and we deem those sectors at carbon leakage risk. So there are different channels for carbon leakage. The first one is the short-term competitiveness channel, meaning that when companies have to face higher emission costs, those costs that is caused by carbon pricing will make them lose market share if they're not able to pass through those costs in their prices. So if they increase their prices, they might lose market share, and that will make them lose competitiveness compared to companies that do not face this increase in costs. Another effect, which is a long-term competitiveness effect, is effectively the difference in returns on capital. For example, if in companies that invest capital in Europe see their return lower than invest in, say, in China or in the US, eventually in the long run, they will relocate their capital in those countries with less stringent climate policies. So that's the long-term effect, the investment channel, or as we call the investment leakage. Another effect of carbon leakage is the commodity price channel. So the reduction in global energy prices could be expected to increase demand for fossil fuels in countries with less stringent climate policies. So for example, if you have the shale gas boom in the US, companies there benefit from lower energy costs than in Europe, for example. And the last channel is actually a reverse channel, is the technological spillover channel, which actually, with carbon regulation and with higher carbon prices faced by companies, for example, in Europe, this will lead to technological investment to become more energy efficient. So actually, carbon regulation results in a reverse leakage, because this company then become more efficient, and then it improves their competitiveness compared to other companies not facing this carbon pricing. So this is an overview of the carbon leakage risk and the different channels that those energy intensive or electro intensive companies can face this carbon leakage risk. So how does this carbon leakage risk can impact industries? Mainly, we talk about two different types of costs, the indirect cost and the direct carbon cost. So when you put a price on carbon, the CO2 price, this can effectively impact industries through the direct channel, the direct cost, because they have to buy through auctions the European emission allowances, or if they are on the carbon leakage list, they will benefit from free allowances. But mostly industries will have to buy those allowances. So this is a direct cost for companies that have to cover their emissions through those allowances. The second type of carbon cost is what we call an indirect carbon cost. So carbon pricing will be passed through by power suppliers through their electricity prices that industries will have to pay. So we assume that there's a direct pass-through of the carbon pricing through the electricity price. So when industries have to buy their electricity, they will also face this, what we call indirect carbon cost, because the electricity grid is not 100% decarbonized, so they will have this carbon cost included. So those are the two types of costs of the carbon leakage. So now we'll pass over to Fabien.
So let's maybe spend a little bit of time on a number of questions. I think it's a good time to stop. And thank you for those of you who are typing questions. So I will read them so that everybody understands the question we are addressing. So there is the first question that has come in about whether it is possible to couple carbon markets. So the short answer to that is yes, of course, but the long answer is that it's difficult. Why? Well, what you are doing when you are coupling two markets is that you are obviously creating opportunities for trade. And we know that this creates value overall, but it also creates what we call as economists distributional effects, meaning that if you have a higher price market and a lower price market, we will of course have a process of transfers, and some will win, some will lose. So there's going to be a political tension naturally here about the tolerance to carbon prices, which may be different in different parts of the world. So yeah, as an economist, I think we are all seeing the possibility of coupling markets as one of the major advantages of carbon markets. It's one of the reasons why carbon markets are often put forward as a superior approach to a tax, which is essentially something difficult to spread, if you want. But at the same time, the practicalities of coupling markets, and in particular the political dimension, is a difficult one. So I think we have a second question. The second question is whether a carbon price is only applicable to direct emissions, point you mentioned, or whether it can also be applied to embedded emissions. And if I can interpret the question is, of course, if you have a country which is producing a lot of goods which are exported in the rest of the world, a lot of the emissions which are embedded in this good are actually for consumption of the good somewhere else. So it's important to look at emissions not just in terms of production, but also potentially in terms of consumption. Now, that's an excellent question, and economists have been wrestling with that issue for a while. It would theoretically be possible to have carbon pricing, either taxation or a cap and trade mechanism, being based on the embedded emissions, so the production of carbon as opposed to the content of the carbon of a good. But in practice, what you would need is to be able to trace in the full value chain for each one of the goods the embedded carbon content. And that is actually something which is quite challenging to do in practice, not impossible though. It would require, of course, a number of methodologies, a number of norms, and I think this is something that is obviously a promising area for further research going forward. It's actually, I think, a good transition to the third question we have, and then I will perhaps stop. We have a question on whether international trade strategies, for instance, the trade war, at least it's called the trade war that had started between the US, China, would affect carbon leakage. And we have also a question on whether we have a view on border tax as a policy. And the reason I'm linking these two questions is because there is a link. A border tax adjustment can be one of the solutions to level down the playing field, in the sense that you correct at the border, either for the embedded carbon content of your imported goods, or for some measure of that carbon content that you want to tax, which does not have to be exactly related to the carbon content embedded. And this is where it becomes difficult, because if this becomes an import duty, or if it becomes perceived as an import duty, then you are back into the geopolitics of international trade. And obviously in the current context, where we have trade barriers and import duties escalating, you may ask yourself, well, that's a different context than before, and maybe this is an opportunity for Europe to think about border tax adjustments in a different way. And yes, indeed, I think that given the change in context, we need to put all of these issues on the table and see whether border tax adjustment cannot be, and in my view, it can be part of the solution to create incentives for other countries around the globe to adopt carbon pricing strategies. So if you allow us, I think given the time constraints, we will continue with the presentation, and perhaps we will take a few more questions at a later stage in the presentation. So the next topic in our presentation is to think about an economic framework to deal with carbon leakage and to evaluate the risk of carbon leakage. So there are a number of factors which you see on this circle which are relevant when evaluating the risk of carbon leakage. If you start from the left, what we have just told you with Catherine is that, yes, obviously, whether a country like or a continent like Europe has carbon pricing and its neighbors have carbon pricing will play a role. So this is a European and global carbon pricing evolution. In an ideal world where all of the countries would put in place carbon pricing at the same level, then we wouldn't have an issue of carbon leakage. So that brings me to the second box at the top, which is a carbon price level. Because you can have potentially carbon pricing everywhere, but you still have a potential leakage problem if the level of the carbon price is uneven. And currently, if we look at the carbon prices in the ETS, in some of the other schemes, there is a very significant difference. So it's not just a question of whether or not you have carbon pricing, it's also a question of the level of the carbon price. Then, if you want to identify the risk for a specific sector, a specific industrial sector, we have to look at the characteristics of this sector from an economic point of view. This is what we refer as the industrial structure and market characteristics. I will provide some more details on that in a minute, but let me perhaps cover the last 2 points I have not covered yet. What's important also in the context of carbon leakage is all of the other drivers of competitiveness that will drive the choice of production and of investment of industries. So in that sense, you could say this is not directly related to prices, but the differentiated costs for input prices, for taxation, for different types of levies will also play a role in driving leakage. It's not directly linked to carbon, but of course, this is something to take into account when looking at carbon leakage risk. And finally, policy responses to the risk of carbon leakage. We will come to that in the context of Europe in the end of the presentation, but of course, in a country that has put in place compensation, the risk of carbon leakage will be different from a country which has not put in place compensation. So that's obvious, but it needs to be said. So as I said, I promised I would tell you a little bit more about the way we economists look at the question of the pass-through. What is the idea of the pass-through? Well, the idea is that if you have an industry which is incurring additional costs because of carbon, it will only be in a difficult position vis-à-vis its competitors if that industry is not able to increase its price to the consumers who are purchasing the good it sells. Because if the industry has an increase in cost, but is then able to increase its price, it will keep its margin the same. So this is why it's extremely important to understand not just the increase in cost, but the ability of each of the different sectors considered to pass through the additional cost to their final consumer. Now, there are a number of factors which will affect this ability of an industry to pass through the cost to the downstream consumers. You have, as a starting point, of course, the market structure. Is your market competitive, or do you have market power? For instance, do you have one or two dominant companies? What we know as economists is, of course, that fully competitive markets will tend to internalize the variations in cost, and therefore the prices will reflect the pass-through. It's not necessarily the same where there is market power. Then we have demand elasticity, which will play a role, as well as the supply side sector, which is facing more competition. If facing more competition, if the supply is more elastic. So these are, of course, important, the slopes, if you want, of the demand and supply curves. Then we have sector-specific parameters. First, let's talk about technology. If there is possibility to learn about new technologies, if there is international spillover of technologies, then there is an ability to adapt quickly to change in cost, meaning you can switch to another technology and you will not be affected in the long term by an increase in carbon cost. So there needs to be also a differentiation between the sectors where technology improvements are possible at relatively minor cost compared to other sectors where there is a very significant jump in technology required to reduce emissions. Just to give you an example. Another relevant factor is transport costs. An industry in one country is going to be protected to some extent from carbon leakage if transporting the good it produces is quite costly. Because then even if its competitors in other countries have a cost advantage, they will not be able to compete in the whole market of that industry because the transport cost will be just too significant. And finally, protection, of course, of certain industries. There are myriad of possible interventions in industrial policy to favor domestic production over international production, and that needs to be accounted for. So I hope this gives you an overview of how we as economists think about that issue of pass-through and of carbon leakage. And the important conclusion from that is that each sector to some extent is unique. What I'm showing you here is a table that is taken from a study from the European Commission from 2015 on an investigation ex post of the pass-through of the cost related to the ETS in different sectors. So you see that the test, the econometric test, has been done for a number of countries. It is significant in some countries, and you see on the right-hand side an indication of the pass-through rates. And you see a very significant difference between some countries, for instance, cement, and the different types of cement, or for instance, petrochemicals, where you see that the pass-through rates are not the same. So why is that relevant? Well, of course, if you are a policymaker, you will want to make sure that you identify, A, whether there is a legitimate risk or not of carbon leakage, depending on that ability to pass through. And B, if you think there is a legitimate risk and compensation is needed, it will need to be calibrated to be proportionate. And again, this kind of information on the pass-through, as well as other things, will be relevant. So let me stop here, perhaps. I think it's a good time to see if we have a little bit of additional questions. So I think we have one question, which is about the meaning of reverse leakage. Do you want to say a few words on that?
Yes. So indeed, the reverse leakage in this context is actually, as you said, a positive effect in the sense that because your company is facing a carbon price, instead of this being a negative impact of your company, it will incentivize you to invest in new technologies that will make you more efficient, and you will actually be more competitive than companies that are not facing those increased carbon costs. So it's actually a reverse effect of the carbon leakage risk. So it's a positive effect indeed.
Very good. So I think the other questions we have are around compensation policies. So my suggestion is that we address them when we come to compensation policies, which is the fifth part of our talk. So just to remind you, we mentioned to you there are two main types of issues. You have the direct carbon cost related to the cost of the CO2 you emit, simply as Catherine said. And then you have the compensation for the potential indirect cost you may incur via the increase of the electricity price. So why don't you start, Catherine, with the direct cost, and I will take the indirect ones.
Thank you, Fabien. Yes, indeed. So we've presented to you the carbon leakage risk and how it might impact industries, depending on if they have the ability to pass through their costs. So here I'm going to present to you how the European Union can put in place compensation mechanism to compensate certain industries that are facing direct costs. So first of all, we want to assess who is facing this direct cost and who is actually exposed to a significant risk of carbon leakage. And this industry will be eligible for compensation for their direct emission costs with free ETS allowances, meaning they don't have to pay those allowances to cover their emissions. So the European Commission has assessed the carbon leakage risk of certain industries, and in particular energy-intensive industries, to determine which sectors are eligible for those compensation. And those sectors are included in a list called the carbon leakage list. So there's been a carbon leakage list published for each phases of the EU ETS. So you have one for phase 1, phase 2, phase 3, and most recently phase 4. So the ETS directive has been revised in 2018 for phase 4, which goes from 2021 up until 2030. And so the methodology to assess if a sector is exposed to significant carbon leakage risk is first a quantitative assessment. So you can see here on the slide, the European Commission calculates a product of the trade intensity of the sector multiplied by its emission intensity. And if the product of that is above a threshold of 20%, we deem the sector as significantly exposed to carbon leakage. So trade intensity is just a measure of how much the sector is exposed to international competition. Obviously, when we talk about carbon leakage, it is the risk that a company would transfer abroad and eventually pollute more. So the trade intensity parameter makes sense in this product to measure this exposure to international competition. And then the emission intensity relates to how much the energy and how much the sector uses energy. So how much emissions the sector consumes compared to its gross value added, for example. So if the quantitative assessment is not successful, the sector can still be eligible through a qualitative assessment if the product of its trade intensity and emission intensity is above 15%, or if the emission intensity parameter is above 1.5. So then the qualitative assessment will look at different criteria, the market characteristics and the ability to pass through cost, for example, the ability to reduce its energy consumption, which is what the DEC refers to, the abatement potential, and then the profit margins, which effectively looks at how much the carbon cost here, the direct cost, will impact the long-term investment in the sector in the European Union. So looking at those different criteria, then the EC can determine if that risk is eligible for free ETS allowances. So we can see that the revision of the ETS directive reduced the number of sectors eligible. So in phase 3, 177 sectors were eligible for those free ETS allowances. And now, since 2019, 50 sectors and 13 subsectors are eligible for free allocation. So you can see, as an annex of this of the slides, you will find a table with the carbon leakage list for the phase 4. So the sectors that are deemed carbon leakage risk receive 100% full allocation, and some manufacturing industries that are not included on the carbon leakage risk but still face some leakage risk will receive 30% of free allowances up until 2026, and then this will be phased out. So I'm going to show you on the next slide, an example of free allocations compared to direct emissions in the non-ferrous metal sector. So this graph shows you is relevant for the third trading period, so 2013-2020, and it shows for different sectors that are deemed at carbon leakage risk. So primary aluminum, for example, copper, lead, zinc, their emissions compared to how much allowances they receive. So if we look at primary aluminum, the blue bar will show you its expected emissions over the third period, and then in green, the allowances that the sector will receive. And as we can see, although the sector is deemed at significant carbon leakage risk and receives 100% free allocation, it doesn't necessarily mean that this covers the whole emissions, because those allowances are calculated with a benchmark. So if the sector is at the benchmark, it will receive 100% of its allowances, and if you do not hit that benchmark, you actually receive lower than your emissions. So you still have an element of incentives to become more efficient through this benchmark. So this just gives you an example of how those allowances are calculated and compared to their direct emissions. And now I'm going to hand over to Fabien to present to you the indirect compensation mechanism.
Right. So again, at the risk of repeating ourselves, what Catherine described is the European Commission approach to compensate for sector at risk for the direct emission costs. There is also a provision for the compensation for indirect costs, and this corresponds to the cost induced via the electricity price channel. Now, importantly, there is a difference, and that difference is that it's up to the member states, it's up to each country to put in place compensation. That compensation is state aid, and therefore it is something that needs to be, of course, compliant with the stated rules at the European level. And the European Commission has defined a framework in the previous ETS phase and in the process of revising the guidelines from 2012 for the next phase to deal with these indirect emission cost compensation. So we are presenting to you the framework that was in place up to now. And what we see here is, again, that there are two criteria which are going to be decisive in deciding whether your sector is eligible for state aid to compensate for the indirect costs via the electricity price. These are the trade intensity and the ratio of indirect CO2 cost over the gross value added of your sector. So again, different ways to compute these things. We see the thresholds: 10% for trade intensity, 5% for the ratio of indirect CO2 costs via versus gross value added. But you can also look at these different things individually. So that is for the eligibility. And the result based on the 2012 assessment was that 13 sectors and 7 subsectors have been called eligible for state aid. Now, once you're eligible, of course, you want to know how much you can get, and this is a calculation of the aid. You see the formula here. It's pretty simple. The formula you may think is complex, but actually the idea is pretty simple. There is a maximum element, which is a product of, well, first, a net intensity factor, which is currently set as 75%. Then what matters is, of course, the CO2 content of the electricity you consume, because in a country where you emit carbon-free electricity, then you are not going to be exposed to carbon leakage, where in a country where there is essentially carbon-intensive plants, you can imagine that the indirect effect via the electricity price of the carbon price is higher. I will come back to that in a minute. We will show you how this CO2 emission factor was determined in the different countries and regions. Then, of course, the price, and here what it looked at is the ETS forward price matters. And as Catherine said, what's important is that there needs to be a benchmark for the different products defined, a benchmark which will define the electricity consumption efficiency. So if you are the most efficient in a sector, you can hope to be fairly well compensated. If you are the least efficient, then that gives you an incentive to improve. And finally, you've got, of course, your baseline electricity consumption. So what we can do is perhaps take a look at some of these coefficients to make them a bit more concrete. We have here a map of Europe. This is to show you how these emission factors were computed in the previous period, so the ongoing period, the phase 3. The emission factor can be a very complex computation, because essentially what you would need ideally to do is to look at every hour what is setting the marginal price of electricity and whether that plant is emitting carbon and how much. Now you understand this is quite a difficult exercise and one needs to simplify. So the European Commission has used a simplified approach, which is to look at the average carbon content of the thermal plants, which are the ones very often being marginal. And based on that, you see the coefficients that have been computed for countries or regions, because that's the other dimension to consider, which is in some countries, the electricity prices are very much similar to neighboring countries, for instance, because of market coupling or very strong interconnection. And therefore, the carbon content of the electricity price will be driven not just by the mix in one country, but by the mix in the region. So the Commission defined both relevant regions, and that was largely based on price convergence. So where price convergence was strong, a single coefficient was defined for the regions, and where, of course, price convergence was not so strong, then different coefficients were used in the different countries. And you see here a significant variety of coefficients across Europe, reflecting the variety of the mix, but also of what is setting the price in terms of whether or not neighboring countries have an impact. Perhaps the other things that we can discuss is the benchmarks, and Catherine, you can say a few words on an example we have.
Yes, as we've mentioned before, I've discussed the benchmark as regards the direct emission, and Fabien has also mentioned how the efficiency benchmarks are used in the formula for the compensation for indirect carbon costs. So those benchmarks are calculated. You have different benchmarks. You actually have the product benchmark, the heat benchmark, process emission benchmark. But we're going to focus on the product benchmark here, which is estimated by the Commission at the start of a trading period for sectors. And it relates to the 10% most efficient installations within a sector. So the example here that we've put is the aluminium benchmark curve. So you can see that the benchmark value is for the 10% most efficient installation, and that mostly all the other installations are way above that benchmark. And what's important about the benchmark is that it allows to maintain incentives for those installations above the benchmark to still be efficient, because one could say that the objective of the EU ETS is to incentivize companies to become more efficient, and by compensating them either through free ETS allowances or the indirect compensation, that reduces this incentive. But actually, by putting in place those benchmark, you can still mitigate this impact and still maintain this incentive to become efficient. So those benchmarks are set at the beginning of the period, and for the phase 3 of the ETS, they were not revised, and to avoid overcompensating certain industry that might, throughout the period, become more efficient, the European Commission has introduced a degressivity parameter to the aid intensity to make sure that the compensation received by industries decreases over time, so that if certain technologies or breakthrough technologies happened during the trading period and are not taken into account the benchmark, this will still avoid overcompensating those industries. So this was the methodology in place for phase 3, and as Fabien mentioned, the methodology for the phase 4 for indirect cost compensation is still being considered by the Commission at the moment.
So perhaps it's time to
approach. I think so. We've given you an overview today on carbon pricing, carbon leakage risk, the different mechanisms in place to compensate this industry. As we said, to understand first the impact of carbon leakage risk on the competitiveness of the energy-intensive industries, we need to first look at the market and sector-specific parameters that will determine if those sectors are negatively impacted by the carbon price, and if they have the ability to pass on those higher costs. And depending on the ability to pass on those costs, those industry might be facing different degrees of carbon leakage risk. So given that certain industry face this risk, we've presented you the framework in place to compensate the direct and indirect carbon costs. So with regard to the direct carbon costs, we've presented you how the Commission compensates the industry with free ETS allowances. And in 2018, the Commission has published the carbon leakage list, which includes a list of all the sectors that are eligible for those free ETS allowances. So this carbon leakage list is for the phase 4. And with regard to indirect carbon costs, the EC is currently revising the methodology to determine the eligibility of sectors to receive compensation for their indirect carbon costs. So the list will be, the current list is the 2012 guidelines, and this list will be revised for phase 4. So the challenge here, as we've said, is first to assess the carbon leakage risk, assess the degree of that risk, and how we can compensate the industries, and what is the optimal aid amount. And there are 3 main objectives for the European Commission here when deciding which sector should be compensated and by how much. First of all is to mitigate the risk of carbon leakage. So you have to make sure that you select the right industries, the ones that are most exposed, and you give them the appropriate amount of compensation, otherwise they will transfer their production. So you have that first objective, but at the same time you still need to maintain the incentive of the EU ETS, which is to become more efficient. So you need to preserve the price signal of the EU ETS. So that is why, for example, you can see in the formula of the compensation, it's not 100%. You still have a compensation that makes it give an incentive for industries to be cost efficient. And the last one is by introducing those subsidies to those industries, you also need to make sure that you minimize the competition distortion within the EU, because certain industries might receive compensation in a country while another member state has not put in place a compensation mechanism, and that could potentially create distortions as well. So the EC, while deciding those carbon leakage lists and optimal aid amount, has to take into account those three objectives. So I think that's pretty much it for our presentation. If Fabien, you want to add something?
I think it's probably a good time to take questions. And yeah, we have one question that's actually directly related to your last list of objectives for a good policy framework. We have been asked whether there is any impact of changes in this compensation and the need for long-term visibility, if you want, for the industrials. And I think that's a good point. We could have had it here. You want to put in place a framework that is something that can be anticipated in the long term to some extent by market players, because if there is change or too much change, or change which is not predictable, that's also an important point, from one period to the next, then it's of course difficult for the industrials to have long-term predictability and visibility. So that was an excellent question. Let me scroll down the list of questions. Just give us a couple of minutes to. So we have a question, a couple of questions which are clarification questions. There's one which is about the pass-through rates, which we showed, the table, and the question is whether these are short-term, long-term results. These are, to my knowledge, results done from the European Commission based on ex-post results, so a number of years before 2015. So therefore, it cannot be very long-term because we had only limited data. And of course, what is also limiting for us economists is that the ETS also is not so new anymore in terms of the compensation framework. We don't have a very long history to work with. So that's of course a caveat we need to have here. We have another question which is about policies to deal with potential carbon leakage beyond just compensation. And I think the question is whether there is a trade-off between free allocation, which is one way to compensate industries affected, and border tax adjustment, which could be another way to do it. I would add perhaps a third way to deal with the root cause of the problem, which is carbon leakage, which would be to have sectoral agreements. So if you look at all of the sectors, you could say we will have an agreement not between countries, but between sectors across different countries so that they are facing the same carbon costs. So there are a number of just voluntary initiatives on sectoral agreements, which I think should not be underplayed. I don't believe it's going to be something that can lend itself to a massive rollout on all sectors, but for a number of sectors which are proactively engaging in the fight against climate change, that can be a way to actually level the playing field without having to resort to compensation. Now, to your question on pros and cons, if you want, of border tax versus free allocation, I think there is a big difference in the incentives which are created for third countries. Free allocation does not create any incentive for third-party countries to reduce the carbon emissions on their side, whilst if they face a border tax adjustment, the competitiveness of their exports is affected. So they have an incentive themselves to potentially, via that mechanism, go for the cleaner technologies. And finally, there is another point I can think of, which is that the two measures have very different implications for the state. if you give away free allowances, you reduce the state revenues. And if you introduce a border tax adjustment, actually you increase, everything else being equal, revenues. And this is money that can be then redistributed, as you know, or reused for environmental policies, so that you can potentially have what economists call this double dividend effect. So we could carry on. I'm not saying that one policy is better than the other, but I've explained to you, I think, my belief that given the change in context, perhaps we should give a second look to carbon border tax adjustments. Let me see if we have perhaps a final question, because I see the time is running. So we have a very good question about whether ETS costs related costs are being compensated. This will actually reduce the incentives of industry to reduce emissions. And I think this is another question we have. If you have 100% compensation, what is the incentive to reduce CO2 emissions? Well, I would say the fact that you are compensated, or the fact that you pay or not for your credit, meaning free allowances or not, to some extent, yes, play a role, but you still have an opportunity cost of CO2. Let me explain. Even if you get 100% free allowances, if you were to invest in your factory so that you were to reduce emissions, even if you are compensated for all, what you could do is you would then be able to resell the carbon credits you have in excess because you've invested in that new technology and make money out of it. Because on the other side, you have a carbon market where some people are buying. So I think this is the beauty of a carbon market versus a tax. It's the idea that whether or not you are allocated for free your credits, this still has a value and it still gives you an incentive to reduce emissions. So I hope that clarifies the question. Well, I think that was the last question, and I see we are nearing the end of the hour anyway. So I suggest that we close. So we would like, Catherine and I, to thank you very, very much for spending this hour with us. We hope that was useful to you. We have a bit of literature for you in our slide deck if you're interested. And perhaps I will say a few words on a training course we have if you are interested to have a bit more on these topics. We actually have in October an executive course on electricity markets and carbon markets in Florence. It's a 2-day program. We will have plenty of good food, but also plenty of hopefully fascinating discussions. And there is also a digital program to prepare for the 2 days executive training that will go more into the depths of these carbon issues. So I hope perhaps to see some of you at this training course and to be in contact with some of you on other occasions. Thank you very much for your attention today and look forward to staying in touch.
Thank you. Thank you to all. Thanks for tuning in today to listen to us and enjoy the rest of your day.